Valence electrons in the periodic table. What are valence electrons? Well, valence electrons is an electron in the highest occupied energy level of an atom whose tendency to be held or lost determines the chemical properties of that atom. So valence electrons are the electrons at the highest energy level. So I should say in this number. So let's take a look, for example, at magnesium, which has an electron configuration of 1s2, 2s2, 2p6, and 3s2. And we use electron configurations because, again, they tell us about the electrons, and it gives us the energy levels of the electrons. So here, we can take a look and see that magnesium has 12 electrons. 2 plus 2 is 4, plus 6 is 10, 10 plus 2 is 12. And that gives us 12 electrons. Now we have to find the valence electrons. And the valence electrons are going to be easily found because we know that the highest energy level occupied is 3, because 3 is the highest number here, so that must mean it's the highest energy level that those electrons occupy. So magnesium has 2 valence electrons because in the energy level 3 it has 2 electrons because of this. It has 2 electrons because this 2 signifies 2 electrons, and it's in the highest energy level. So we call those valence electrons. So those valence electrons are very important because they help us understand the chemical properties of the atom or different elements. So another way to know how many valence electrons there are is to look at the periodic table and know the group numbers. So this is where it is important to know the group numbers. In this periodic table, here we have the periodic table. I'm going to label the group numbers: 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. So those are the group numbers. These tell you the number of valence electrons as well. So the reason that is that, let's take, for example, hydrogen. When we do hydrogen, when we write out its electron configuration, we see that it's 1s1. Li is going to be, it's going to have He. I'm going to write it in short form, abbreviated form. He, 2s1. And what you're going to notice is that these all end in s1, which means that they all kind of have the same number of valence electrons there, because that's the highest electrons that Li can have. 3s1 is the highest Na can have. K can only have 4s1. So the pattern here shows you that all of these only have one valence electron. And if you write out the electron configurations for each group, you'll notice that at the end they have the same number of valence electrons. So here, when you see 1A, that means it has one valence electron. And 2A, as you could guess, probably has 2 valence electrons. 3A has 3 valence electrons. 4 has 4 valence electrons. 5A, 6A, 7A, 8A, corresponding to the group number. So this is a quick and easy way to understand, to know what the the valence electrons are, by using your knowledge of electron configurations to understand that each group number represents also the number of valence electrons.